Okay, see Lindelof videos, calculus, implicit differentiation practice. Practice is what I've been doing because I screwed this problem up like 15 times. So it's not really hard. I'm getting tired and I'm not paying close enough attention. So maybe that's the lesson here for all of us. So here we go. I am going to start to differentiate this. You can tell, right? You just look at this and you think of what this would look like if you graphed it, and you can see that this thing would have to be graphed implicitly. So on the exam, they're not going to ask you to do implicit differentiation. They're going to ask you to differentiate, and most probably at a point. So let's just do this. So here's my notation. This is just my signaling to you that I intend to take the derivative of this piece, and lastly this piece. And that's what I'm going to do in order. So the first derivative of any constant is, right? So here's a constant which is 1, and the derivative of that constant is 0, right? It's a horizontal line. The first derivative of 3x is just 3. So that is actually pretty easy. But then if you look at this second piece, you can see it has two problems. One, it's a product rule, right? It's this times this piece. And here, this is y squared, so we know we're going to have to take this derivative implicitly. We're going to take the derivative of y, so we're going to have to do so implicitly. So the product rule says take the first part of the function, which is 2x squared, times the derivative of the second part of the function. So 2 times 1 is 2y. Then the derivative of this inside piece, and the derivative of the inside piece is dy dx, right? Going to continue with the product rule, which says that now we're going to take the second part of the function, y squared, and times the derivative of the first part. So the first part is this 2x squared, and its derivative is 4x, isn't it? I'm going to clean this mess up a little bit here. Well, look at that. There's the answer, kids. Look at him go. I tell you, I screwed this up before, like 3 times. I'm like a little bit pissed, but I guess I'm going to be all right. And you're like, why does he keep talking? Just shut up and work. Okay, sorry. So I am going to do that. This is where people do screw this up. Like these 2's right here, you do multiply those to get 4x squared y dy dx, right? This shit does get cleaned up here, so it is 4x y squared. Remember, our goal is to solve for dy dx. So there's tons of ways to do it. What I'm going to do is move this piece over and then go from there. So that's going to give me negative 4x squared y dy dx is equal to all this crap that's left over. That's this 3, sorry, that's this 3 and this plus 4x y squared, so plus equals 3 plus 4x y squared. And now, obviously, to get rid of this, I need to divide by this piece right here. So I'm going to get that my dy dx is equal to the opposite of 3 plus 4xy squared all over 4x squared y. And if you're wondering why I didn't put the negative sign down at the bottom, it's just cleaner, and that's most likely what you would see it on the exam. But you can put it either one, and I actually have seen people take it and multiply it through the numerator. I don't know why you would do that, but you could do that. Also, remember here that what is most likely going to happen is that they're going to give you this, right? They're not going to ask you to differentiate this. More likely, they're going to ask you to find the derivative. So they're going to give you an x value and a y value. And when you do, you take those numeric values and you plug in the x value and the y value wherever you find them, right? And then you do your arithmetic. That's how you're most likely to see this on the multiple choice section of the test. Look, thanks for hanging in there with me. If you have any questions or comments, please let me know. And if you haven't already subscribed, what the hell, right? Thanks.